All right, and again, I am going to ask to see your guys' notes, your folks' notes at the end. So please follow along. And if you have questions, if you get stuck, if you need me to slow down or whatever the case might be, it's okay. And I want to know. I don't want to leave anyone else behind at all. Remember, we're doing this as a group. We are a community learning math together right now. So if I'm leaving someone behind, then that's not good enough for me. That's not good enough for you. So just tell me. Just tell me, and I want to slow down and answer your questions, please. So today, Math 1A, it is Wednesday the 6th, Wednesday, October 6th, and we are reviewing functions. And then at the end, I want to start looking at something called function notation, okay? So this is new, function notation, but reviewing functions, this is going to be more review on what we've been doing. So domain and range of functions, and determining if a relation is a function or not. And doing some plugging in of numbers for a function and finding outputs, plugging in inputs and getting outputs. So those are all the skills I want us to be able to do for this unit. Okay, so recall with me that a function means every input has one unique output. Every input has one unique output. And remember, input means the domain numbers, the independent numbers, the x numbers. Okay, so whenever we have our equations, x is the input and y is the output. So let me add that in over here. So output means the range, just another word. It's like a list of all the outputs. These are the dependent. These depend on the first ones. These depend on the x's and the y's. So these are all basically the same thing. A function means every input has one unique output. And another way we look at this is that means no repeated inputs. So if we're looking at a list of our domain and our range, and if we see repeated inputs, that means it's not a function. Not a function if we have repeated inputs. And then the last test that we had to tell if we have a function is the vertical line test. Vertical line test. If a vertical line crosses the graph more than once, it is not a function. So this we would use if we have a picture, if we have a graph given to us. So here's the different ways to tell, is this relation a function? I'm going to just hold this here for a moment. I'm assuming people are copying this down. I'm going to wait like 12 seconds and then we will move on. Okay. Any questions on this review so far of how we know if we have a function? We're going to look at some problems now. No questions? Okay. So don't copy all this down yet. Just try thinking about these with me. Okay. Don't spend your time copying it down right now. Do any of these represent a function? What I have here are 4 different displays of relations. So I'm going to label them. This is number 1. And then the table next to it will be number 2. Down below, the bubbles with numbers, that's number 3. And then finally, our graph is number 4. So do any of these represent a function? Well, how can we even know? We have to use those rules from the previous slide. So we're looking at the inputs and the outputs. We're looking for repeated inputs. That means no function. If we have repeated inputs, that means it is not a function. So we talked about this yesterday in the Kahoot and afterwards. If we have a list of points like number one is, what we're looking at here are different ordered pairs of inputs and outputs together. So the first number is always the x. The second number is the y. That's 1 point right there, 0, 1. And then 3 comma 2, that's another x and y, and so forth. So the domain for number 1 is all the first numbers. The inputs for number 1 is all the first numbers. So do you see any repeated inputs on number 1?
No.
Okay, let's make sure for sure. We're looking at the first numbers. So we see zeros an input and it goes to 1. Okay, cool. Are there any other zeros in the like first position? No. So we're good on that. 3 goes to 2. And I check the rest of my list and I do have this point right here. It also starts with 3. So that means 3 as an input goes to 2, and then later 3 as an input goes to 4. That's the problem. That means it is not a function. Why? Because 3 is going to 2, and then later 3 goes to 4. That's a repeated input. That's what we're looking for when we're trying to figure out, is this relation a function? So this is not a function. It's disqualified because of the repeated inputs of 3 going to 2 different places. Let's do number 2 next to it at the top here. This is a table, and it's a sideways table, you might have noticed, not a vertical table like I usually give you guys, you folks. So remember, X means our input, Y is the output. And they didn't label it that way, did they? They just said X and Y. So we need to remember, oh yeah, X means the domain. X is the input numbers. Y is the output numbers. So we scan through our table here, -5. That doesn't happen again for inputs. -1. -1 happens here and here, going to different numbers. Because it doesn't have unique outputs. Remember the first, I'm going to go back to this quick. The very first definition, the official math definition for a function, is the top one here. Every input has one unique output. That's the problem. We have the same input with non-unique outputs, like different outputs basically. -1 goes to 7, -1 goes to 1, and that's a problem. That's a repeated input, so this is not a function because those -1s. We saw it in number 1 on the left, and now we see it again in number 2 on the right. 1 is a list of points, ordered pairs, and 2, a table. Remember, there's all these 4 ways plus an equation that we can use to show a function. Okay, now let's look at number 3 below there. I see there's something in the chat. Oh, Maria. Yes, thank you. I'm sorry I missed your message. You were totally on though. Yeah. Maria said no to number 1. It's not a function. Good job. So in the bubbles on number 3, I guess I haven't shown you these yet, but this is basically a table. Okay, so what we're looking at, see the arrows going from the first bubble to the second? So this is our list of inputs where the arrows are coming from. And then we have our outputs where they're heading to. So we see -4 goes to 5. Cool. Then we have 9 going to 7. We have 13 going to 3. And then we have negative 7 going to 5 again. Now, you might think this is a repeated input because we have two things going to 5, right? But actually, what we're seeing is a repeated output. If I wrote this out, negative 4 goes to 5, no problem. And then later, negative 7 goes to 5. Okay, so yes, the 5 is being repeated, but that's not the input, right? 5's not the input, 5's the output. So this is okay. These aren't the same. The inputs are different. So this is a function. Woohoo! Finally, we got an actual function. Any questions on number 3 or on the first two? No comments, no questions, no concerns, no worries, no fears, no joys? All right. Look at number 4, the graph with me. Now, we could figure out what all the different points are, like the different locations of each one, and make a table out of this. But honestly, that's extra work. Let's not do extra work if we don't have to. We have a tool that we could use to solve this now, the vertical line test. So it's not a straight line function, is it? It's not continuous. It's a discrete function. Or it's a discrete relation, I should say. We're trying to figure out, is it a function? But we can still use the vertical line test. So draw a vertical line through the function or through the relation. Okay, so the first point right here, it doesn't hit more than once, but the second one does. If you try to draw a vertical line through that guy, it hits the one below it, right? You can see it's right below. So because the vertical line is crossing through the relation, the graph, more than once, it's disqualified, not a function. It failed the vertical line test. So just to remind you, vertical line, cross, I'm going to say the graph, right? Our graphed points, cross the graph more than once, not a function. So that's how we're trying to determine when we're given a list of numbers, or a list of points, I should say, from number 1. If we're given a table like number 2, or if we're given the number bubbles like number 3, the input output bubbles, or number 4, an actual graph, we can use the vertical line test on it. Okay, I told you you didn't have to copy all that down because it's a lot of different stuff to copy down. I just wanted you to think about those and try them and practice it with me. So no big deal if you didn't copy it down. I did want to move on and try some more, and I do want you to start trying to copy down some notes from these. So I'll take a second, and I want you to copy down these 4 points that we see. Negative 1, 1, 0, negative 1, 5, negative 11, and 10, negative 21. In our 2 questions this time, what is the domain of this set of points, and what is the range of this set of points? We want to find what is the domain, what is the range, and I do want you to copy this down in your notes, please. We're going to list off the domain as a group, a set of numbers. And same for the range. I'll do that on the right. I want you to try this first. And if anyone is willing to share what they get for the domain or the range, please let me know.
Is the domain negative 1, 0, 5, and 10?
Anaya, high five from far away. Boom. I wish I could give you a candy bar or something else as a fun, reward. Yes, very good. You said negative 1, 0, 5, and 10. The domain is the group of inputs, which we know now is the first numbers. So that's -1, 0, 5, and 10. When in math, you've seen me do it. You've seen it in Edmentum. We often use these fancy parentheses, brackets, to hold a group of numbers or a group of points. So that's what I'm writing here, the fancy squiggly brackets to hold my domain, and the same for range. Can anyone else, because Anaya just answered, can I hear from anyone else who knows what the range is in this question? Any ideas?
It would be the 1, -1, -11, and then -21.
Wonderful, Levi. High five to you. A legitimate, real high five from far away. Levi found the second set, right? It's the second group of numbers is the range. So I'm going to list them off. 1, -1, -11, and -21. Cool. Follow-up question. Is this a function? Can anyone tell me? What do you think? And this, Anaya, Levi, you can answer too. Any thoughts? Is this a function, this set of points? Let me erase my markings here. Can we figure that out? Do we have enough information for that?
I'm pretty sure it is a function
Yes, you're correct. It is a function. How can we know that? Any idea why it is?
because we don't see any repeated numbers on the left-hand side, on the side that's the domain.
I love it. You're so right. There are no repeated domain numbers. So we can say for sure that this is a function. There are no repeated domain left side numbers. Oops, left side numbers. Awesome. Oh man, I missed some good stuff in the chat. Maria Celeste, high five to you as well. She says, yes, it's a function because the numbers aren't repeated. Absolutely. Remember, folks, we are looking specifically, though, for that first set, right? The left ones. Good. So just make sure we're thinking about those. It's okay if the right ones are repeated. It still could be a function. It's the left ones, the inputs. Okay. Let's try another question. Okay, this one is a picture, so you don't have to copy it down, but try to focus on it with me. I tried to zoom it in as much as I could. So let's just practice this one verbally together, okay? This doesn't have to be in your notes. What is the domain of the graph function and what is the range? So this one I think was tricky for a lot of people yesterday when I threw it at you. I wanted to practice it again. Now remember, domain means the list of all the inputs. Range means the list of all the outputs. But when we have our graph, that corresponds to like the left right for domain. I'm going to write that down. It's the left right like border basically of how far our graph goes. And then what is the range? That's the height, the up down border. Now I tried to make it as big as I could. I'm hoping people can see this from your screens at home. So forgive me if it's blurry. Would anyone like to take a stab at the domain here? How far left does it go? How far right does it go? And what I'm looking at is the green line, right? And it's capped off with endpoints. So can we use those endpoints to tell how far left, how far right this function goes for its domain? I'll give you a moment, and if anyone would like to try or share, let me know. Okay, no one's jumping in. So let's talk about it. When we're asking about domain range, it is harder, isn't it? When we're not doing a list of numbers like we did earlier. Here, we're looking for kind of like the boundary or the border, so to speak, of like where does our function end and begin. So for domain, I want you focused on the x horizontal axis, the x line, the x ruler. It really is just a ruler. So I look at my green line and I say, how far left is it? Well, it doesn't go past right here. Doesn't go past right here. See that? And we're only concerned about where does that fall on the x line. And I'm going to write this here. This is the x-axis, and it's not actually the domain, but it goes with domain. So I'm going to write domain next to x, and I'm going to write range next to the y, okay? Because they go together. Y goes with range, x goes with domain. So for my green line, I see it goes to this spot on the ruler. So that would be -9, 8, I think 7, -7. So we've got to count those squares. Make sure that we know how far that is. It doesn't list all the numbers, right? So I had to figure out how far that is, -7. It's 3 spaces back from the -10. Now let's do the same thing for its left rightness over on the right side. So it doesn't cross this line. So I'm going to look up above that and see where is that, right here. That would be 1, 2, -2. So for the domain of this picture, this graph, the domain is in between. Think about it like this. It's in between -7 and -2. How we write that with our math symbols is that x is greater than -7 and less than -2. So I'm using my inequality symbols to show the domain. X is bigger than -7, but it's also less than -2. It has to be squeezed in between. And notice that how we write it is kind of like the x is squeezed in between the two boundaries, -7 and -2. Okay. So we found the domain. We got to find the range still. It's the same exact process, except we're just looking at its heights, its up, down, like boundaries. So I'm going to change my color to purple. And now I'm going to look at how high does it go? How low does it go? Remember, if it travels off the screen, if it has arrows on the line that's telling you, symbolizing, oh, this thing goes on continuously forever, then you could say it's going to infinity, or it's all real numbers if it's both directions, up and down, or left and right. We don't have that in this problem. It's bounded by those endpoints. So we're looking at where does it stop at? It's for its height, it doesn't cross here. And look over to the right. Where is that? That is at 8. And how do I know? I'm just counting the squares. 1, 2, 3, 4, 5, 6, 7, 8. Then how low is it? It's right here. That's at 9. -9 rather, isn't it? -9. So the range is in between -9 all the way up to +8, in between -9 and 8. Now, when we're talking range, those go with y, not with x. So I'm going to say y is in between. Y is bigger than -9, but less than 8. So I think this was a tricky problem for a lot of folks yesterday. Might still be today, and that's okay. I just wanted to go over it again with you. Before I move on, any questions or concerns, comments, please. What are you guys feeling so far after this example, again, about domain and range of a graph? Okay, and if no one wants to share, I want to see your thumbs. I want to see where you're feeling on this problem, finding domain and range of a graph. So please turn on your cameras for a moment and show me with your thumbs up or thumbs sideways or thumbs down for this last problem we just did. Levi's feeling pretty good, thank you. Maria, thank you for your feedback. Robel, awesome, good to hear. Thank you for your feedback, Robel. Everyone else, please let me know. Where are you at? Anaya, appreciate your feedback. Thank you for telling me. I think I'm going to find a way to practice this tomorrow without just me doing it, right? I want to make a lesson tonight that will give you some interaction with finding those domain and ranges. And not just one person, everybody, because I think it's going to benefit everyone if we get more real practice with that, not just watching Josiah do it, but you guys doing it. Okay, where's everyone else at? Is everyone else asleep? No chats. If you didn't show me your thumb, where are you at? Tell me how you're feeling. Anthony, thank you for the feedback. Okay. Where's everyone else at? Savannah, I appreciate your feedback. Thank you. And Brooke, awesome. Thanks, Brooke. Thanks for your feedback. All right. Oh, and I missed the other Anthony. Thanks to both of you, Anthony Ravelis and Torres. Thanks to both of you. Okay. That's better. Did I miss anyone else? All right. Thanks, folks. All right, I think that's all I had for now with domain and range of a graph, but I want to do more tomorrow. So bear with me. And tonight I'm going to try to find something more interactive that you can get hands-on with this. So stand by. Tomorrow I hope to have something to go over this more with you. Okay, this is important. So this is a little bit of a different topic. So back to notes. Write this down. Given the domain of -4, 0, and 5, what is the range for the relation 12x plus 6y equals 24? So take a moment and copy this down, and then we're going to solve for the range that goes with this domain that they're giving us, okay? And this was another one that I think some folks were feeling good on yesterday, and some folks were still in the process of learning this and feeling confident in this. So this is another thing that's super important. I want everyone to feel better about this before we get too deep in the woods in math this year. Okay, so we're going to hit up this topic a lot more too. They're giving us a group of inputs. They're giving us domains. They're giving us x's. These are all x's. So what we need to do is plug in or substitute in one at a time these x numbers and find the outputs that go with it. So our answer, here, let me put that at the top here.
Josiah,
Levi.
I can't see your screen.
Oh, am I not sharing?
I think you stopped screen sharing.
Oh my Lord, thank you. I'm so glad you told me, because I would have just kept going. Sorry, everybody. Okay, let's start that over. So, sorry, folks. Here's the new question. Thank you, Levi, for telling me. So, given the domain, -4, 0, 5, that's a list of x numbers. Then we want to know what is the range for the relation 12x plus 6y equals 24. So this equation you're seeing, that is the relation. Maybe it's a function. But this question's calling it a relation, so let's just stick with that. I guess we don't really know yet. I mean, in our domain list, there's no listed repeated inputs. So this is probably a function. But at any rate, when you see it in equation form like this is either a relation or a function. It's got two variables. Remember how we defined a relation? It's a relationship between two quantities or two different variables. That's what we see here. 12x plus 6y equals 24. So x and y have a relationship of some kind. So we're going to use the equation. We're going to plug in our x's. Remember, x's and domain, those are like the same thing. This is a group of x's we need to plug in one at a time. And then for our answer, it's going to look like a list of numbers just like the domain. It's a list of the range numbers. We need to find them though. So I'm just kind of setting it up at the top. So how do we do this? We're going to take our equation, 12x plus 6y equals 24. And this is like where things get mathy, right? We're going to start doing some arithmetic now. We're going to plug in our x numbers one at a time for x. Let's start with -4. So since it's 12x, that means 12 times x. Remember that. So this will be 12 times -4 plus 6y equals 24. So this is back to unit 1 when we were practicing solving equations. So now I want to solve this for y. Okay, so simplify. Do the multiplication. 12 times 4, I think, is 48. Remember, if one number is negative, then the answer is negative. So 12 times -4, -48. And we have plus 6y equals 24. Now remember, the goal here is to get y equals a number. We're solving it for y. We're isolating the y. So this is where we want to undo the actions happening to the y. It's being added to the -48. So we're going to have to cancel that out. And it's being multiplied to 6. We got to cancel that out as well. So since this is a plus -48, what's going to counteract -48? A positive 48. So we have to add a 48 to the left side of our equal sign and to the right. Remember, the equal sign, the equation, is like a balanced scale. So the left side equals the right. So if I add 48 pounds to the left, I've got to have 48 pounds added on the right. Okay, those cancel, and we get 6y is whatever 24 plus 48 is. 72. Double check in your calculator. 72. And now 6 times y, I undo that by dividing both sides by 6. And we get y is equal to 12, I think. Yeah. Okay, so that was just one answer. We've found one y value. That is in our range. So 12 is the first number in our range. Look above there. We're adding 12 to our list. But we've got to do it again. So now we've got to do it again, plugging in 0, and we're going to plug in 5 after that. So I'm going to draw a line here. And we're going to do the whole thing again, but plugging in 0. So we plug in 0 for x. And this is kind of nice because the 0, remember there's another math rule. 0 times anything is always 0. So 0 times 12, we can just cross that out. It all became a 0. So we're left with 6y equals 24. Like last time, we're dividing both sides by 6. Y equals 24 divided by 6, the number 4. So 4 is the next number in our range. And now we've got to do it a third time. So we're going to plug in back to the beginning. Remember the equation that we started with? That is the relation. That is the function. So whenever we start over, remember you're starting over when you're plugging in a new number for x from the very beginning, from like how the equation started, not how it changed when we did it the other times. 12x plus 6y is 24. All right, we plug in 5. So solve this through for y. I want to let maybe someone's already done it, or maybe someone's working on it now. Hopefully everyone's working on it. I want all of you to be trying to solve this. And if someone could share with me what you get for the output when you plug in 5 for input, please let me know. So I'll wait a moment, and if anyone could share with me what you get, I appreciate it.
I got y equals -6.
I think that's right. Good job. Would you mind walking me through that?
So 12 times 5 is 60 plus 6y equals 24. And then subtract 60 from both sides. So the 60 and the 24. And then, yeah.
And 24 minus 60 in my calculator gives me -36. Is that what you got?
Yeah.
Awesome.
Oh, and then divide both sides.
And
Cancel.
cool. And then you ended up with -6, right?
Yeah.
Anaya, high five from far away. Thank you. So that fills out our range. We had 3 inputs, right? -4, 0, 5. So we should have 3 outputs when we're all done. And there's our numbers. All right, good job, Anaya. And I hope everyone else was trying to follow along with that. Any other questions, concerns before we look at something different? Okay. All right, so this is an example of having a function or a relation, right? This was called a relation, but having either of those, and we're plugging in inputs, working out the math, and getting an output. And this is pretty common. This is something I would rank as important in Math 1. So I think I want to do this more tomorrow. I'm not going to let it go. We're going to kind of keep practicing our domain and range. We're going to keep practicing just plugging in inputs and getting outputs. Okay, but now I want to just briefly start some new material. So here's some new material called function notation. Function notation. So let's start this today. And then tomorrow, I think I want to dive into domain range again, solving for output, solving for y's, again, like we just did. And we're going to do more of this tomorrow too, function notation. Now, notation, folks, notation just means how you write things. How you, or how we, right? How society, how any group of people, how we write things. Okay? So if you've ever used cursive, which I used to know how to do cursive, and I've totally forgotten how to do it, but that's just another type of notation. versus like normal non-cursive English writing like I'm doing now. Um, let's say if you're taking notes, well, you're taking notes in a class right now. Let's say you're a scientist, okay, and you're like keeping track of an experiment and like the results you're getting in your experiment. You're using different notation than you and me are used to, who aren't scientists yet, right? Um, I probably would look at a scientist notation and not really understand it, but it's just shorthand for how they're writing things. And that's what we're going to look at with our function notation. There's a different way. This is a different way to write our function equations. So our old way, let's see, I had an example, but I think I lost it right before class. So I'm going to make one up. So an old way to write in a function equation would be y equals, we'll say 5x plus 3. Okay, so this is an example. I'm just making it up. There's lots of different function equations, but here's one. And this is our old way, y equals 5x plus 3. With function notation, the new way, we write it like this. F of x is equal to 5x plus 3. Notice all that's changed is instead of writing it as y, it's written as f parentheses x. And how I say it, how we read it in math classes and math world, math peoples, f of x. So I'll bet money that a lot of you have seen this already in other classes or somewhere in life with math stuff. You've probably seen f parentheses x, and maybe you've wondered, what the heck is that? Is that f times x? It doesn't mean f times x. It means output, okay? Remember, y is our output, x is our input. Well, that's the same down below with our function notation. F of x means the output. X still means the input. And how I read it is f of x. Remember, we're not really changing how we use functions or solve for outputs or anything like that. It's just a new way to write it, okay? F of x. Any questions right now? Concerns? Comments? Any questions? Okay. Anyone need more time? No. Okay. Let's keep using this example of equation. So y equals 5x plus 3. I want to look at how we do function notation with a table. Tables with function notation. We've been using tables, and we like to put the input first. So I'm going to say x first. Make a table with me, please. Follow along. And let's just put some spaces here. We're going to fill it up with some numbers in a minute. Our output, instead of y, I'm going to write it as f of x. Say this out loud with me. F of x. You don't have to turn on your mic, but say it out loud. Practice it. No one can hear you. F of x. A lot of times people are, hesitant to use this math language. And you know what? The worst that could happen is you might sound kind of silly to yourself, but I guarantee you no one else cares, and no one's going to judge you while you're learning your math vocabulary. So please practice it. F of x. So our input is good old x, our friend, and then our output is this new thing, f of x. Okay, now let's practice some inputs and find the outputs. We've got a few minutes left, so let's start off crazy with a -1 input, and then we'll do 0 and 1 and 2, and 3 if we have time. Why not? All right, and what is the function? Let's use the one from the last, when I started. It was, I just broke a rule. I used y. Y equals 5x plus 3. And I want to write that with my function notation. So I'm going to write it as f of x equals 5x plus 3. What we're going to do is use our equation, our function equation, to find the outputs for these inputs. This is my domain, -1, 0, 1, 2, 3. And let's find the range for that domain. Okay, so another thing to know about function notation is when we plug in our -1 for x, so let's start that below. I'm going to plug it in for both of those x's like this. And what's happening is I'm keeping track of what input, which domain value I plugged in. So how I read this is f of -1. F of -1. I'm plugging in that specific number value, right? So I read it as f of -1 is equal to whatever's next. Now on the right side, we can actually do some math and solve this business. So we get -5 plus 3. And what is that? -2. -5 plus 3 is -2. So we got our first output. And how I would write this is f of -1 is equal to -2. That means our input was -1 and the output is -2. And then we would just proceed like normal to find the rest. So let's find a few more here. F of 0. So we're plugging in a 0 for the x's. It's going to be 5 times 0 plus 3. 0 times 5, remember, that knocks it out. It goes away. 0 times anything is 0. So we have 0 plus 3. And we can cross it out. We don't even need it. 3. So f of 0 is equal to 3. How I say it, f of 0. F of 0 is equal to 3. So let's put that in our table. I'm hoping you folks are seeing that the math isn't changing. All we're doing is writing our equation a little different. We're writing it as f of x, or f of some number, okay? F of some input. Let's try another. F of 1 is equal to 5 times 1 plus 3. I'm just using the same function each time. We're switching out x with the new input value. 5 times 1 is 5. Add 3, and we get an 8. Sweet. So f of 1 is 8. Any questions or comments or concerns right now? Okay, I guess we'll do one more, and then I'm going to stop, and I want to see people's notes, please. So not right this sec. Let's do one more, and then I want everyone to turn on your cameras, show me your notes. I want to give you a giant star and tell your teachers that, yes, they're coming to class and they're following along. They're asking questions. They're participating. So that's your opportunity to show me your notes. In just a moment, let's plug in 2. F of 2. So start from the beginning. 5x plus 3, right? But my x needs to switch out to a 2. So 5 times 2 plus 3. That's 10 plus 3, and that gives me a 13. So f of 2 is 13. So our input table basically looks the same, but we're calling it f of x. So I don't want you to be, I guess, worried, confused if you see that f of x and wonder, what the heck is that? Well, it basically just means y. It means output y. Okay, it's not anything too different. We're just writing it differently. Function notation. And when we're doing our formulas, our equation solving, you can keep track of your input the whole time. That's kind of the nice thing. F of 2 down here, what we just did, well, that means 2 is my input. So it's keeping track of what you started with. It's keeping track of what the domain or input number was. And then at the end, you get your output. We got 13. All right, if there's no questions, I'm going to stop sharing this. And I want to see people's notes for the day. Anthony R., high five, dude. Let me mark you down, and then you're good to go. All right, Joseph. Joseph, thank you so much. You're good to go. Anaya, high five to you, dude. Boom.